All right, guys, first thing I want you to notice is that this is an absolute value function. So this is where we got to watch out for where the derivative not necessarily equals to zero, but where does the derivative not exist. So I've got to find the critical numbers. So the first thing I need to do is I need to know what the derivative of this function is. However, this is not a this is an absolute value function, so I can't just take the derivative. I've actually got to separate this into a piecewise function. In other words, two pieces. So f of x, I'm going to break this up into two functions. This is the absolute value of x plus 1. So remember, with absolute value, I can have just x plus 1, or I could have the opposite, or negative x plus 1. And then the way that we figure out our restriction over here, you take the x plus 1 and you set it basically greater than or equal to 0. So this is going to be x is greater than or equal to negative 1. So it's the positive value when x is greater than or equal to negative 1. It's the negative value when x is less than negative 1. So, for example, if I plugged in like negative 2 into here, negative 2 plus 1 is negative 1, and the absolute value of negative 1 is 1. That's the same thing here. If I plug in negative 2, plug in negative 2 into here, negative 2 plus 1 is negative 1, and then negative 1 is 1. So you end up getting the same value. Now that you've got the piecewise function down, we can take the derivative of the piecewise function. So the derivative of this piecewise function, the derivative of x plus 1 would just be positive 1. The derivative of negative x plus 1 would be negative 1. And then my restrictions are still there. But notice, this is what's crucial, guys. The derivative on the right-hand side, right, because x is greater than negative 1, the derivative on the right-hand side is a positive 1, and the derivative on the left-hand side is a negative 1. Well, those two derivatives at this point, at negative 1, don't match up. So if the derivatives aren't the same, and they don't equal each other on the left-hand side and the right-hand side, then the derivative does not exist at that point. So again, the reason why is that the derivative as x approaches negative 1 from the left-hand side is negative 1, and then the derivative of x as x approaches negative 1 from the right-hand side is positive 1. Those two values do not equal, therefore the derivative does not exist at x is equal to negative 1, and then by definition that is one of my critical numbers.